Hello, my name is Zihan Wang. I'm doing the optional assignment of computer science, 4375 introduction of machine learning. And this essay I want to discuss and make a presentation. As you can see, this essay is the introduction of the century, and the author is J.R. Quinlan. He's working in the Center of Advanced Computer Science, New South Wales Institute of Technology, and Sydney. And this essay was published in the August 1st, 1985. And here is the essay itself. Here is the printed slide itself. The first page is about the introduction of the title and the title paper and the author itself, as we can see in the essay itself. The second page is about the introduction, and you can see this paper focuses on one macros of the machine learning and on a family of learning systems that have been used to build knowledge-based systems of a simple kind. Section 2 is about to outline the features of this family and introduce its members. All these systems address the same task of including decision tree from example, and I will, after a more complete specification of this test, one system, which name is the ID3, is described in detail in the section 3 and 4. Section 5 presents the extension to the ID3 that enable it to copy with the noisy and its incomplete information. The paper concludes with two novel initiatives that give some idea of direction in which the family may grow. As you can see, there is some really abstract concept here, such as ID3 and the family of learning system. I will give the introduce of them and elaborate what is the relationship between the decision tree and them in the later slides. The section 2 is beginning the introduction of the TDID family of learning system, and it says it might appear that classification tests are only a minuscule subset of the procedural tests, but even activities such as the robot plan can be recast as classification problem. It introduces the significance of the classification problem in the machine learning algorithm. The next example is the next slide gives us some example, such as the first is a diagnosis of the medical condition for a symptom, in which the classes could be either the various disease state or the possible therapist. The second one is determine the game value of a chase position with a class Wang for white, lost for white, or drawn. And the third one is decide from out of space observation whether a severe thunderstorm is unlikely, possible, or probable. So this just introduce some kind of aspect that we can use the decision tree to work for them, such as make a forecast of the weather, also make a forecast of the in a chess gaming. The paper 6 is still introduced of the TDID family, and the members of this family are sharply characterized by their representation of acquired knowledge as decision tree. This is a relative simple knowledge formalism that lacks the expressive power of semantic network or other first-order representations. As a consequence of this simplicity, the learning used in the TDIDT family are considered less complex than those employed in the system that can express the result of their learning in a more powerful language. So however, it is still possible to generate knowledge in the form of decision tree that is capable of solving difficult problems of potential significance. And then the system are present with a set of cases, and it is relevant to a classification test and develop a decision tree from the top down. guided by frequency information in the example, but not by the particular order in which examples are given. So this gives you the basic concept about the descent tree and what the rule is followed. And here is the summary. So the system describes developed descent tree for the classification test, and these trees are constructed beginning with the root of the tree and proceeding down to its leaves. The family name emphasizes that its members carry out the top-down introduction of the descent tree. And this figure shows a family tree of the TD-ITT system. As you can see, the ID3 here, generated by 1979, will be introduced in the next page. Okay, here we go to the ID3 system. ID3 and it was mainly discovered by the author is one of the series program developed from the CLS. The CLS is the beginning of this family tree. In response to challenge introduced tests posed by these people to decide from a pattern-based feature along whether a particular trace position in any game is lost for one side or in a fixed number of the play. A full description of ID3 will be in the section 4, and so it is just sufficient to note here that it embeds a tree building method in an iterative outline shell, and abandons the cost-driven looks ahead of the CLS with an information-driven evaluation functions. And we still discuss about ID3 system. The bottommost three systems in the figure are just commercial derivative of the IC3. It demonstrates the importance of the IC3 and what can derive from them. They incorporate many user-friendly innovation and utilities that expense of the text generating and using descent tree. They all have industrial success to their credit. For example, point to a field enrichment application in which the company was able to boost the revenue by more than $10 million per annum through the use of one of them. It just introduced the value of and the benefits by using the commercial derivation of the ID3. Sorry, I had a mistake. ID3, not IC3. And the section 4 is about the ID3 and the relationship between ID3 and the induction test. The basis of the universe of objects that are described in terms of a collection of attributes, where each attribute measures some important feature of an object and will be limited here to taking a set of discrete maturity inclusive value. For example, if the object was the Saturday morning and the classification test involved the weather, attribute might be outlook with the value such as here you can see the summary, overcast and rain. This is about the temperature, and also with the value cool, mild, hot with the humidity. Also with the high, normal in the windy, with the value true, false taken together. So this attribute provides a zone source order language for characterizing objects in the universe. So as a result, we can see the outlook have the overcast, temperature have a cool, humidity has normal, and the windy is false. All of these are attributes of the outlook object. And here is an example of descent tree. By using the example here, we can see the outlook have the three subtree about the sunny, the overcasting, and the rain. And here is also the object humidity and the windy, high, normal, true, false. Also, each object in the universe belongs to one of set of maturity include class. To simplify the following treatment, we'll assume that there are only two such classes, denote P and N. Although the extension to any number of classes is not difficult, in two-class introduction text, objects of class P and N are sometimes referred to as positive instance and the negative instance, respectively, of the concept being learned. Also, ID3 would designate for where there are many attributes and training set contain many objects, but where a reasonable good decision tree is required without much computation. It has generally been found to construct simple decision trees, but the approach it used cannot guarantee that better trees have not been overlooked. Also, the basic structure of the ID3 is iterative, which means that a subset of the training set called the window is chosen at random, and a decision tree formed from it. This tree correctly classifies all the objects in the windows. All other objects in the training set are then classified using the tree. If the tree given the correct answer for this object, then it is correctly for the entire training set, and the process terminated. If not, a selection of the incorrect classification object is added to the window and the proceeding continues. In this way, correct decision tree has been found, and after only a few iterations for a training set of up to 30,000 objects described in terms of up to 50 attributes. So this is about the introduction test. In the introduction test of ID3 system, how can the system work and what is the power of the system work? We can shrink the attributes into a small set of objects to make the data become more clear, and we can get some conclusion about the static of the data we are currently analyzing. And here is an example of the data set. And we will use this example to make a calculation. As you can see here, the expect information required for this tree with the A as root, so it is a formula like this. The information gained by the branch on A is therefore like this. So as a conclusion of the 14 objects, 9 are of class P and 5 are class N. And the information required for classification is as we can see about here. By using the data here, you can make a compare. And the expect information requirement of the testing this attribute is therefore 0.694 bits. By using the same formula, we finally find the gain of outlook is equal to 0.940, and minus E outlook is 0.246 bits. And similarly, the analyzer finally give us the result as the gain of the temperature is 0.029 bits, humidity is about 0.151 bits, and the wind is about 0.048 bits. Also, here we come to the section 5. Section 5 is about noise, and this gives us a basic introduction about the information supplied in the training set has been assumed to be entirely accurate. Sadly, but the introduction tests based on the real-world data are unlikely to find this assumption to be tenable. The description of objects may include attributes based on the measurement of our subjective judgment, both of which may give rise of error in the value of attributes. So some of the objects in the training set may even have been misclassified. And here we go to the summary. There are mainly two arguments with this essay. The first is that if one or more attributes are adequate, this is mostly possible to construct a decision tree that correctly classifies each object in the training set. And usually there are many such correct decision trees. The two is how could the system develop decision tree for classification test. Trees are constructed beginning with the root of tree and proceeding down to its leaves. The formula of this palindromic name emphasizes that its member carry out the top-down introduction of decision tree, as we introduced in the before. So here is a basic summary about given the concept introduction and the example of this essay. The summary of the whole essay. So it gives us the concept introduction, example of induction text, and it says that a universe of objects that are described in terms of a collection of attributes, where each attribute measures some important feature of an object, and we'll limit it here to taking a small set of discrete maturity inclusive value. And ID3 was designated for a spectrum where there are many attributes and the training set contains many objects. It's basically purposed to serve a construct simple decision tree, but the approach user cannot guarantee that better tree have been not overlooked. And nodes will always exist because the introduction tests based on the real-world data are unlikely to be absolutely tenable. The nodes can cause a more comprehensive set of attributes to appear in the ID code. And about the critical, main strand is that the author proves that the accuracy of the decision tree by skillfully using the data static to take calculation and adapt algorithms, and prove that the point of view through the data family is obtained. And the main weakness is that the article is too academic, and too many professional terms, explanation, and citation makes the meaning of some articles difficult to understand without really strong academic background. And also, I have some informal opinion about this essay. The clarity is not positive. The continuity of various aspects is not strong. The relevancy is inactive. Correction is hard to find. And the accuracy is pretty good. It uses the elements in the example to express the concept of attributes in the decision tree. And finally, the conclusion. And the final conclusion side is about introduction of decision tree. It introduces a TD IDT family of learning system and the induction text, ID3, and noise. So I basically understand the preciseness and the convenience of using decision tree as a technology for building knowledge-based system. I also have understood about the implementation of decision tree in the different aspects in the system, such as the ID3. I understand the existence and the influence of noise. I also know the sort of history of decision tree as well now.